Okay, so that so section B total we have 490 watts. Okay, now C is actually a bedroom space, so it's a bedroom. Again, count the lighting points. We have total. We have one, two, three, four, and five. So lighting point we have five in the C. So just enter the number the five. So five numbers. Okay. Then fan. Actually we have only one ceiling fan. So just enter one the. Then exhaust fan we have one. In toilet space we have one exhaust fan. So just enter one. 6 ampere sockets. Again just count the number. Here we have two, three, four, five. Okay. So including the shave socket here. Okay, these are 16 ampere, so don't add right now. So 5, 6 ampere sockets. Okay, so 5 number here. Now we can count the totals. Okay, so 5, 6 ampere socket means 5 into 60, 300 plus we have one exhaust fan, one ceiling fan. So 60, 60, so total 120 plus. The lighting actually we have to check because the lightings we have 11 watt and 20 watt are mixed here. Okay. So these are actually 18 watt. These two are actually 18 watt. This one is 20, this one is 11, and this one is 11. Like that it is. Okay. So that 11 plus 7 we have plus 22 plus 218 watt, right? So 18 plus 18 plus then 120 watt. So plus 20, 498. Then anything else? Okay. So for 98, so I'll just do one thing, I'll just round off and make it 500. Okay. So in the bedroom space, we have total 500 watts. Okay. So C is done. Then actually D and E are both bedroom itself. So I'll do one thing, I'll just consider as what typical condition. So that D and E will have the same load. So I'll just delete. I'll copy this one. Okay. 500 here and 500 here. Okay. Same number of points. Okay. Then D, okay, you can just copy this one as well. Copy B, B, F, C, D. So I think we have only F, right? Okay, only F. Okay. So that bedroom is done. And then finally we have kitchen space. So kitchen again. Let's count the components here. So one, two, three, and four. So four lighting points. Okay. So that enter the number four here. Okay. Then ceiling fan. So we don't have any ceiling fan here, right? Yeah, no ceiling fans are placed. So just leave it. Then exhaust fan again, we have one exhaust fan. So just remember the one. Then 6 ampere sockets. 6 ampere sockets actually we have required one, two, three. So three 6 ampere sockets are here. Okay, so remaining are 16 ampere. Okay, so three 6 ampere sockets. Okay. Now so again 6 ampere again. So 180 plus 160 watts plus 60. Then four lighting, right? So four lighting actually in the toilet space we have two 11. This is 11 watt. This one is 20 watt. So 40 plus 11. So 40 plus 11, 291. I'll just round up to 290. Round off to a 295 or something. Okay. So that's it. That's our what light load calculations. So all the sections A, B, C, D, E, F is what included here. Okay. So same like we design like our normal DB. First we have given all the light loads, then we'll move to the power load here. Okay. So in the power load, the first connection is given for this one. Okay, that is our AC. Okay. So for now, we just consider that I'm considering this as a 1 ton AC. For a 1 ton AC, approximately around what 1,200 to 1,500 will be the wattage range. Okay. So that first connection after the bedroom, I'll give for the AC. That is, the load will be 1,200 watts. I'll give. Okay. And the point, I have one 16 ampere socket. Okay, so here actually it's not 1,002. Okay, I'll just do one thing. I'll edit this one. Okay, so I'll edit this to a 16 ampere switch with a 1,200 watt. Again, this will change. Okay, this is not standard actually. Based on the manufacturer and based on the capacity of the machine, the switch rating and the wattage, everything will change. For example, I'm just giving a 1,200 watt for that particular AC. Okay. So that have one, again, can enter one here. One 16 ampere socket with a wattage of 1,200. So that the total will be 1,200 here. Okay. If you want, you can just copy this one. Okay. Then you can just write down like AC. You can give the name for that. Okay. AC, this connection is for the AC. Then second connection, second power is given to the same bedroom itself. Next connection is given for the geyser. Okay, so geyser again I'll consider 1,000 watts. Okay, again geyser again based on the capacity and everything it will change. For example, I'm giving 1,000 watts for the geyser. Okay, so 16 ampere socket. Again I'll enter one here. One. Okay, then the total load will be again 1,000 watts. Okay, then this one again copy. Okay, update here. Then again just move this one and you can add a name here as well. So suppose it is GY geyser. I can enter the name here. Okay, so this connection is for the geyser. Okay, so geyser is after that. Next connection is going to kitchen here. Okay, next connection. This is given for the both oven and this one. So oven I'll just consider it 1,000 watts again. For a normal 16 ampere socket, I'll consider 500 watts. Okay, so total 1,200 watts it will be. Okay, so that next connection is given to 116 ampere socket of 500 watt. So I'll just give one here. One more two connections are given here. That one is 1,000 watts. So again, I'll give one number here. So one and one, 1,500 and 1,000. So total it will be 1,500 watts. Okay. Now final connection is going to the washing machine. Washing machine again, I will give a let's say a 500 watts. Okay. So 500 watts again, give one number. Okay. Then to the washing machine, 500. Okay, so this is the connection as of now we have given here. Again, the same order we have taken the connection as well. Okay, clear any doubts? Okay, so now this one is done. Now we'll move to the cable sizing and the MCB selection. Okay, so as per the standards, just write down here. So for a load, the light load means the load which is less than 500 watt. That's a light load, right? So light load less than 500 watts. Okay. So if the load is less than 500 watts, the circuit breaker we'll be selecting will be 6 ampere and the cable size will be 1.5 millimeter square. Okay. So this is the MCB and the cable size. Okay. And above 500 watts, everything will be power load. So that above 500, above power load, okay, above 500 watts. Okay. So first, above 500 means again we have a lot of ranges there. We can say that from 500 to 1000 watts, we'll be calculating a 10 ampere MCB with a 2.5 mm square cable. Okay. Then 1000 to 1500 watts will be a 16 ampere MCB with a 4 mm square cable. So that's it. This is the condition as of now. Again, so a lot of things are already I already shared uh, the electrical data book. Okay, so in that it's already given the I think in first page or something is given. Hmm. It's given here. Okay, so lighting loads of 6 ampere you can see single pole MCB 6 ampere and cable size is 1.5 ampere. Power circuit 16 ampere 2.5 mm square. Okay, 10 ampere. Then AC load that means above in between 1000 to 1500 ampere you can take what 4 mm square cable and what 16 ampere MCB. Okay, so that's the MCB and the cable size. Okay, so that the concepts are given. Now based on the load we have to what write down the cable size here. Okay, so here I can see that these loads are actually less than 500 watts. Okay, so that means your cable size will be 1.5 mm square and ampere rating will be 6 ampere. Okay, so just double click the, you can write down 1.5. Okay, here and next one also again 1.5. Again, it's actually exactly 500 because I rounded off that one. So again, you can just double click there and again 1.5, 1.5. 1.5. Now here again in the next session, you can see it's 1200. So that means it's above 1000 ampere. So the cable size will be 4 mm square and the load will be, sorry, the MCB rating will be 16 ampere, right? So Here you can add in 4 mm square. Next is 1000. So 1000 you can give 2.5. Okay, not 2.5 mm square. 1500 is again, so that 4 mm square. 500 again. Let's say I'll say still it's a power load washing machine, so that I'll just give it 2.5 mm square. These are actually light load, that's why I given 1.5. So the idea is in this case, in case of bedroom, this is the maximum load. That means if all the components, if all the light, fan, all these components are working at the same time, at that time only the 500 watts will become the load. But in the practical scenario, we don't use that. Okay, we'll be using one light, one fan, so we don't turn on all the equipments at the same time, or we don't use all the 6 ampere sockets at the same time, right? So in that case, it's okay. You can go with the uh, 1.5 mm square. But here's the washing machine. So washing machine from the starting 20, it will be consuming 500 watts. So that in the case of power load, you can go for the 2.5 mm square cable. Okay. So yeah, that's it. The cable sizing. Now here you can go for the MCB rating as well. So all this load up to here, this one is again 6 ampere, 6 ampere, 6 ampere. This one also 6 ampere. Okay. For the AC, it will be 16 ampere. So this is public there, 16 ampere. Okay. Now geyser again, it's 1000. So we can go for 10 ampere. Okay. So if the geyser or the heater size increases, you have to go for what? Again 16 ampere. So let's give 10 ampere here. Then next is again 16 ampere. 16 ampere. The last one again, it's 10 ampere. Okay. So yeah, that's it. Our single phase DP connection. Okay. And here again, give the names as well if you want. You can add the names for each outgoing. Okay. Or it's also no problem. Now next we have to calculate the total connected load. Okay. So total connected load means we have to add the sum of all the wattage. Okay. So just take the calculator and add those numbers. Okay. So I'll start from 410 plus 490 plus then 500 three times. So 1500 plus 295 plus 1200 plus again 1000, 2000, 3000. Okay, so plus 3000. Okay, so 6.89. So 6.9 kilowatt. Okay, so 8.953. So I'll just round off to what 6.9. Okay. So that means our total calculated load will be 6.9 kilowatt. So obviously we can see that's actually more than 5 kilowatts. So it's a three-phase connection itself. So actually in order to show you, I just drawn with a SP and dB. So this is how you give for SP and dB. But as per our load, it's actually not an SPN, it will be a TP and dB. Okay, triple pole neutral dB for three phase. Then maximum demand, again, I can 6.9 divided by, okay, divided by 1.5 into 0.8. So 1.5 into 0.8 will be 5.75 kVA. So that 5.75 kVA. Okay. So that's our total connected load and the maximum demand of this DP. Okay. Now coming to the main incomer, we have a combination of RCCB and MCB. How we can identify RCCB means it's 30 milliampere means it's a leakage current for the RCCB, right? So 30 milliampere RCCB double pole and the rating is 40 ampere. Okay, so how to say this 40 means we can check it here. So here we have 6 ampere 16 is there, then 10 is there. So comparing all these, the maximum rating is what? 16. So the main incomer should be more than that. Okay, so after 16, next available is 25 is there. The next is 32 is there. Okay, so you can place any of these. So I'll just go for a 32 ampere. Okay, so 32 ampere will be the rating for the main incomer here. So yeah, that's our first DB, SPN DB. Clear this one? Okay, so I hope this one is clear. So I'll do one thing, I'll just wind up the session for today. On the next class, we can continue.